Now we'll see a basic animation of a Q data structure. So let us assume that this is the data structure for Q, and in this one we have created an array of size 18 just like a stack, but there are very important thing. One is that here we have a two pointers, one we are calling head and other we are calling tail. So there are 2 pointers in our case. In the case of Q, head and tail. Why we have 2 pointers? The 2 pointers we needed because the pointer head is used when you want to dequeue something and tail is used when you want to enqueue something. So let us see an example how this queue works. So let us start putting some object into this one. So we'll say in queue 23 and press in queue. It will put here and the tail comes here. Put 43. Okay. Put 12 in queue. Put 45. You see that your head remains at the same place and it does not change. When you are doing enqueuing, your head remains at the same place while tail is keep moving, because tail always represents a position where the next element will be inserted. So that is the way the Q data structure works. You have a head pointer which always points which element you are going to remove. Okay, so now let us see. We'll put some more element and then we'll start doing the dequeuing. Okay, so now we have enough element. Now let us do one thing. What we will do is that we'll try to dequeue. So we are starting to do dequeue for us. So now it is time for creating a dequeue. Okay. What happens? 23 is returned back to us and it is gone out of this data structure and the head moved. I will do dequeue again. 43 is gone and head pointer moved to this one. I will dequeue again. 12 is gone and the head pointer moved to this one. 45. Again do the dequeue. 45 is gone and now head points to 100. And that is the way the complete thing happens. Let us see dequeue again. 100 is gone, head moves to here. What happens if I do dequeue again? 65, head moves here. Dequeue, 32 is gone, head moves here. What happens if I do dequeue again? It says that Q is empty. The message it gets, Q is empty. So whenever there is head and tail is same, and it depends on your implementation, but the point is that head always moves whenever you are doing dequeue and tail always moves whenever you are doing enqueuing. And it works in a principle called first in, first out. Okay? Or also known as last in, last out. But most of the books and references will call it first in, first out. So that is the way the Q data structure works. Now, if the queue is full, then it will come back. Now, let us see this. Another example, what happens like this. So, let us assume that you have 23. Okay, 43, 65, 12. You see which is moving? Tail pointer is moving, right? Did you see something interesting? What happened? The moment the tail pointer you put it here, this pointer, this guy moved from here to here. What it means is that in computer science world, in software, the way the queues are implemented, it is not like that you go in a one direction. It will check after it is full in this side. It will go and start from the beginning, and it will start putting the data here, and it will continue until it comes here. Okay. Now, in real life, what happens is that whenever in a queue happens, people move together. So if there is a queue and there is one object here, one object here, one object here, one object here. In the real life, what happened? In the real life, when this goes away, all three moves forward. When this goes away, all two moves forward. But in the queue data structure, the objects don't move, only the pointers move. In the real life, the objects move. In the computer world, pointer moves. Pointer moves means where to put the next object and where to remove the next object. So insertion and deletion, or other way, inqueuing and dequeuing pointers move. So once you full here, it moves here. Now let us insert some more element. "37", we'll put 39 like this, and this one. Now if I want to dequeue, what will happen? It will move this one. See? Okay? Now it points to 43. If I dequeue, 43 goes away. Queue is empty. So this is the way the queue data structure internally works with the help of two pointers, head and tail, and this is a use case of a queue data structure implemented using array. So it is an array based queue data structure. So remember, very important thing, that this was an example of array based data queue. So it is a queue array. We'll see queue using linked list later, but this is an queue data structure based on array.